Hello, everyone, and welcome to the naming game. Okay, enough of that. So, let's start out with the first question. So, NaCl. Name this compound. It is a binary ionic compound, if that helps, which it probably doesn't, but anyway. Okay, contestant number 1, what is your answer?
That is sodium chloride.
Okay. Contestant number 2, what's your answer?
Sodium chloride.
Okay. The correct answer is, indeed, sodium chloride. So, sodium chloride. And this is how we got to the answer. So the first step is you take the cation, which always comes first. So in this case, it's Na, or sodium, and you just write the name out. So that's how we got this part. Second step is to write the name of the anion, which again comes second, or afterwards, at the end. And instead of just writing chlorine, you have to change the ending to ide, I-D-E, which is right there. And that is how we got chloride. And that leads us to the final answer of sodium chloride. So let's just take this, put it over here. Okay, next question. What is the formula of this ionic compound? Aluminum oxide. I'll give you some time for this one as well. Okay, contestant number 1, what is the answer?
ALO.
ALO. Contestant number 2, what is your answer?
Al2O3.
Okay, the correct answer is indeed Al2O3.
Oh, darn.
Nice try, contestant number 1. Okay, so to explain this, there's actually 3 steps for writing the formula of an ionic compound given the name. So the first step is to write the symbol for the cation, showing its charge. So we just learned that you take the cation, and that is the first part, so it's the first part of the name as well. So because of that, we take the first name, which is aluminum, and you write out the symbol for it as well as its charge. So over here, we will do Al plus 3, because that is its charge. The second step is to write out the anion, which can either be an element or a polyatomic ion, but we'll talk about the ones with the polyatomic ions later. So basically, that's going to be the next part. So since it's oxide, you write, again, the symbol for the anion as well as its charge. So we have an Al plus 3 and an O negative 2. So now the next step of this is we use the crisscross method to balance the charges. So basically we take this 3, move it on down here, and take this negative 2 and move it on down there. So we get then Al2O3. And now we still have a little bit more to do. You must divide by the largest common factor to give the smallest whole number ratio of ions. And in this case, the largest common factor is 1. So basically dividing them by 1, or dividing these by 1, I should say, it doesn't change anything. So the final answer would indeed be Al2O3. Okay, so let's move this all to the side. Okay, next question. Write the name of this covalent compound. I'll give you a little bit of time. Contestant number 1. What do you think the answer is?
Tricarbon pentaoxide.
Okay, contestant number 2.
Tricarbon pentaoxide.
Okay, the answer is tricarbon pentaoxide. So indeed, the contestants got it right. So this is how, this is how we got to the answer. Basically, the 2 steps are you take the element that appears first. So in this case, that's C, or I should use red. C, which is carbon. Then you attach the prefix based on the subscript of the element. And that should be in your packet. You see that chart that says monoditri-tetrapentahexaheptaoxanona-deca. So
Those memorized.
you should have those memorized. Yes, you should memorize those. So anyway, so since we see the 3 right there, we use the 3 in the chart or the tri prefix. So that's why we see tricarbon as the first word. And the only exception to this rule of attaching a prefix is if it's only one. If it said CO5, you don't attach mono to the very first word. So if it just said CO5, it would just be carbon pentaoxide. Anyway, step number 2, you take the second element, which again is oxygen, changing the N to I, just like you do for ionic, but you attach the prefix that corresponds with the subscript. So in this case it's 5, and that corresponds to penta. That's why it says pentaoxide. So that is how we got to the answer of tricarbon pentaoxide. My stomach growled. Still recording too. Awesome! Okay, anyway. The very last question is this. Name this ternary ionic compound. I'll give you some time. Okay, contestant number 1, what is your answer?
Monocalcium carbonate.
Contestant number 2.
Calcium carbonate.
The answer is indeed calcium carbonate. Nice try, contestant number 1.
And that is an example of what you do not do.
That is an example of what you do not do. Because again, you only use prefixes of subscripts using covalent compounds. And this obviously is not a covalent compound because we have a metal and a non-metal. So what you do for, in this case, since there is a polyatomic ion, is you use this method. 1, you write the name of the cation in the formula, as you do with ionic. So you take this one, calcium, and you write the name, calcium. Pretty simple. The second step is you write the name of the polyatomic ion, and you do not change the ending. Instead of changing the ending to "ide," you do not change the ending at all. So that's why with CO3, instead of it being carbonide, it'd be carbonate. So remember, do not change the ending. Okay, so I said that was the last question, but there is a bonus question round. Woohoo! Okay, so what is the name of this compound? And be careful. It looks like you could answer this covalently because it is 2 nonmetals, but you have to think about this part right here. Do 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 bum 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 bum. Okay, so contestant number 1, what is your answer?
Hydraulic acid.
Hydraulic acid. Contestant number 2, what is your answer?
Hydrochloric acid.
Hydrochloric acid. The answer is hydrochloric acid.
Same difference.
No, it really is not. Okay, so the steps for this, you must tell whether it is a binary acid or an oxyacid. Binary acids are only acids containing two elements. One is hydrogen and the other is a different element. Oxyacids contain hydrogen, oxygen, and a third element. You'll learn more about these in the future as well, so you should understand that concept. So because this is a binary acid, you'll be adding the prefix hydro, which is this part right here, even though that looks like a hydro, it's hydro. There we go. You will add that prefix, and then once you do that, you write down the element name, but instead of writing "ide," you're going to write "ic." So be sure you know that difference, and then after that, all you have to do is add the word acid, and that's how we got the answer of hydrochloric acid. And I'm going to move this away because oxyacids are another type of base, and I'll actually write down an example just for future reference. HClO3. Okay, and we know this is an oxyacid because there is, as you can see, an H, an O, and another element. So it's kind of the same thing. Basically one of the only differences is that we do not add hydro to this name, so it's not a hydroacid. That's only for binary acids, but since this is an oxyacid, we do not write hydro. Instead, we change the ending of the polyatomic ion. So basically, if the ending is "ate," then you change the ending to "ic." If the ending is "ite," you change it to "us." So basically, this right here is chlorate. So what you do is you change from chlorate to chloric, and then you just put the word acid after that. So basically, that is the answer for that one. Instead of it being hydrochloric acid, since we have chlorate right here, we change, remember, "ate" to "ic" and "ite" to "us." So since that's chlorate, the answer is chloric acid. And that is it for all the naming compounds. Yay, we made it to the end. Okay, since we made it to the end, contestant number 1, do you have any funny jokes to say?
Yeah. Okay, so helium goes to the bar. The bartender says, "We don't serve noble gases here." Helium doesn't react.
Funny. Okay. Well, did you hear, that oxygen and potassium started going out?
No.
It's going okay.
That was a good one.
I know. Anyway, so thanks for watching our video. I hope this helped. I hope it was enjoyable, and those jokes were kind of a reward for watching this whole thing, even though they were very punny. Anyway, hope you enjoyed watching, and if you need any more help, keep searching Corman's page to find other videos. So yeah, we made it! And for all of you that made it through, here is an awkward photo of Mrs. Corman and Mrs. Devaney. Isn't that lovely? That is your reward for sticking this video through, and thank you very much for watching. Peace.